So these notes really require a calculator, and I'm going to sort of take the calculator out and just show sort of what we can do with this. I have the screen up, and you guys should have the 3/8 notes up as well. If I'm going to graph this first function, 160x minus 16x squared, the neat thing about it is that you can only have to change the window once to graph it and the rest of its derivative. Let's play a guessing game. I'm going to bring it up to 1,000, too large, 200, too small, 350, nope, 500, just right. I'm going to change this number over here to -1 because I really only want a quadrant 1 situation, and I want to get a better view of what's going on the right. So I'm going to double click there, tab, and change this to maybe a 14. That's okay. I'm going to right click on, and you guys, for right clicking, it's control menu to hide the equation. So I know that the blue is the original function. I'm just going to slide this up here. Okay, got a good view. Next, I'm going to graph the derivative of that, which you can actually take the derivative by hand, or you can go into the menu and say, I want to take the derivative of f1 of x and graph that. And that gives me this, which I'm then going to hide that, just know that that's the derivative. And then I'm going to press tab and say, we're going to do the, let's do the second derivative. So d squared of the function, and that's going to be of f1 of x. You can also just do the first derivative of f2, and that gives me a derivative as well. Now, why can't I see it? Well, it's probably because I'm way too far high on the axis to actually truly see that, because the derivative would be -32. So let's slide this up, and there we go. And I'm actually going to right click and see if I can change the color of it. No, I can't. I think I can, but I don't want to spend a lot of time. Okay, maybe just a little bit of time. There we go. Line color. Let's make it orange. Okay. So now I have my 3 functions graphed. The question asks to graph the rock's height. Okay. How long was the rock aloft? We want to get some menu, analyze graph, 0, and I'm going to go this graph and right left. So the 0 occurs at 10. So the rock was aloft for 10 seconds. We're going to go back here and write that in for you more visually inclined people to see this. The graph's height, actually I'm going to just keep this like that, so I don't have to keep flipping back and forth. Okay, this is 10 seconds. And how far from the surface is a rock after 3 seconds? I want to do a menu, analyze graph. Nope. After 3 seconds is an input. We're going to go to trace, graph trace, and I'm going to type 3 in. X equals 3, and 336. So my question is going to be 336. Let's see, where am I? How far is it? 336 feet. So that's it. Then we're going to go to the first derivative. How long did it take the rock to reach its highest point? It's asking to analyze this off the first derivative. So I really only want to go to the first derivative. And we're going to do a menu, analyze graph 0 of this function and get that 5, which clearly we know what it's going to be, but I'm trying to use a simple example to illustrate a point. I'm also going to do the maximum here so I can get that point down so you can see what's happening at these different places. So the question again asks, how long did it take the rock? It took 5 seconds. How high did the rock go? It took 400 feet. And what is the velocity at the rock at 0 seconds, 3 seconds, 5 seconds, 6, 8, 10. 0, 3, 5, 6, 8, 10. Let's see how fast we can get these points down. Menu, trace, graph trace, and let's press up and down is going to shift it to different graphs. 0, got that. So 0 is 160, 3, menu, trace, graph trace, 3, 64. And these are all in units of feet per second. So I'm not going to do the rest of these. You can go through and figure out the rest of them, but I wanted to do a couple just so you can see how it's going. continuing, graph A of t is this, it's this line right here, this horizontal line. So we've got that graph. That's y equals -32. And back to this. What is the acceleration of the rock? Well, it's -32 feet per second squared. Okay, so now we will simulate the motion of the vertical motion of the rock, of the graphing calculator. So it says change the mode to parametric. You'll be able to do most of what I'm doing on your graphing calculator, but if you have the newer one, you'll be able to see just a little bit more. Don't worry about it if you really don't. So let's go to menu. We're going to actually change the graph entry edit mode to parametric, and I'm going to graph x is 3 and y is 160t minus 16t squared. 160t minus t squared. And I'm going to press enter. And this doesn't tell me anything right now, but I'm going to enter the following window. So x min, x max, we want 0 to 12. So I'm going to go 0 to 12. And y min, y max is -150 to 500. Okay, and I'm going to right click and hide this so I can get rid of that. And then it wants me to do a t min of 0, t max of 12, and a t step of 0.1. So let's go back up. T min of 0, t max of 12, and we'll change this to 0.1. Okay, change the plotting mode to circle cursor to the left of x of t. Now plot the height. Okay, so let's show what's happening here, where I'm going to try to animate this trace by doing a plot path. This is the part that you can only do if you have the new one. So I'm going to press play, and now time is the variable, and you can see, I know this is like so silly, you can probably fast forward to it, but as time increases, you can see it trace and draw the motion of the graph. Now, you can again only do this if you have the newer calculator or the Inspire CX2. At some point, it's going to reach the maximum height, so you can see that the y value is increasing, and I'm going to pause the animation and change this to be a height of 1,000. Oh, nope. I don't think it's going to come at height of 1,500. Height of 10,000. There we go. Let's make the height be 2,000. So if I go back to menu, analyze graph, menu trace, plot, path plot, parametric, then when I press play, it's kind of creeping upwards, and it will take a little bit of time to get there, but okay, I really do want you to like fast forward right now, like fast forward and watch this thing go, because I can't. All I can do is sit and talk to you and tell you stories. Like, it's raining outside, and this is March 19th, 2020, and we're in the midst of the coronavirus pandemic. So hopefully we all survived and we're all doing okay after this. But apparently the governor just announced that schools are closed until at least May 2nd or May 1st. So that's a change. That's 2.5 more weeks after we plan to come back. The mini marathon's been canceled. Basically all school stuff's been canceled. It's pretty crazy. Okay, that was it. Reached its top peak and it stopped. And it actually stopped when t was equal to 12. Now I can try to speed this up and say, let's go to t to 24, and we're going to do a t step of 0.5. So now when I do a tracing of this and a path plot, it's going to go a little bit quicker. So ready? T, oh, it should have been 0.5. Why is it not doing that? Oh, it traces shortly anyway. Okay, we'll just stop it there. The final thing that it asks you to do on the worksheet is to graph the, change the plotting circle so that x of t is t. So if I go back and change this to t instead of 3, now we're going to see something that looks a little bit more interesting. I'm going to change the horizontal to be not an x of 12. I want it to be an x max of something bigger. Go away. So let's change this to 50. Let's change it to, oh, I need this to be bigger. I need this to be like 10,000. Let's change this to be 100. And then let's change my t-step, or sorry, my t-max to be not 24, but let's change that to 50. And then let's maybe change my t-step to be 200. And you can see what's happening here, that as I start to increase my values, I get something a little bit more akin to that. So this is also kind of a refresher of parametric equations that we did last semester, but let's go to Analyze Graph. Nope, kidding, let's go to Trace, Plot Point, or Path Plot, Parametric, and we're going to press play. And yes, it's going to very, very slow. Don't worry, I'm not going to do the whole thing. It's going to very, very slowly plot the entire thing. I wish you could speed this up, but okay. But that's it. Now, that's all I wanted you to see. We're just simulating the vertically moving rock. That you can simulate motion parametrically. But back to this. I want you now on your own, kidding, not on your own, with a person, with a partner. So do a Google Meet, Skype, something, FaceTime, get someone else and do this with. I will post an answer key to this, but I want you to check it after you've gone through this. This was intended to be a partner worksheet as part of the notes that we would then come together and just check answers with. All this stuff should be fairly evident, and this is posted on OneNote. Okay, that's part of your notes, part of what I want you to do. And then your homework is this worksheet that you should do definitely on separate paper. Even if you can like write on this, just this should be separate paper. All right.